Welcome to Intro to Trigonometry Part 2. So in Part 1, we learned all about the SOHCAHTOA, how to draw the different triangles and why that's so important to have the visual. And in Part 1, we dealt with having the angle given to us in one of the sides. And in this part, we're going to find out how to find the missing angle. So if two sides are given to us, how do we find the rest? First, what's important when we think about the SOHCAHTOA, that it only ever gives us a ratio, right? When we imagine the SOHCAHTOA, if we're looking for the first one, for example, the C, and we say, okay, adjacent over hypotenuse, that only gives us a ratio, right? It gives us 1/2, 5/7, whatever it may be. And then to find the actual angle in the calculator, we need to not just press the sine, cosine, or tangent button, but we actually need to do the inverted function. So that happens with a second function here, and then pressing whichever one you're working with, sine, cosine, or tangent. That's what that looks like with a number, of course. So that then will give us the actual angle of what we're looking for. So just to practice, this is a ratio that we already figured out. So 0.805, 0.8205, 8205. In my calculator, if I now just press the second function and cosine button, it gives me an error message. Yours might do that too. So what I need to do in mine is 0.8205. Always make sure you're putting in the numbers correctly. It's really easy just to mix them up. I need to press the enter button and then second function and the cosine button for this one in particular. That then gives me an answer. So 34.865 degrees. Now, if you're doing perhaps some site layout or you're working with circles and you're looking at arcs, or you need to find out not just the decimals of an angle or degrees, but you need the degrees, the minutes, and seconds. On this calculator, and yours will be similar, we have the DMS function. So that's where you can punch in the angle with degrees, minutes, and seconds. And to take a decimal and to turn it into that, I have to hit the second function and then the DMS button. You can see that it says DEG here for degrees. And that's what it gives me. So it gives us the 34 degrees, 51 minutes, and 54 seconds. Okay, let's try the next one. We have tangent, so 2.0647. Enter button on mine. Second function, tangent, gives us 64.158 degrees. And turning it into degrees, minutes, and seconds, second function, and the DMS button. Here we go. And then that gives us 64 degrees, 9 minutes, and 27 seconds. If I want to change it back, I always just have to remember to hit the second function first. Then it works. It goes right back. If I forget to hit the second function and I just hit the DMS button, it goes right to 0. Just as a reminder, sometimes you forget to punch something in, and then you think you did something wrong, but all it really needed was one extra button to be pressed. Okay, one more practice here with the sine button. So 0.8542 equals second function, sine gives us 58.671 degrees. Second function, DMS button, turns it around for us. So 58 degrees, and that makes sense, right? 58, 58, 40 minutes, and 17 seconds. And the seconds are so small already that we can just round up or down to a full second. We don't really need to go any tighter than that. So I hope that makes sense as a first intro. Now we're going to go into some examples. So we're going to do 6 examples, just like in video part one, of fairly simple ones. And then we're going to do three after that are a little bit more tricky. So if after a couple you feel really good about the simple ones, you can just scooch on ahead to the trickier ones, following along with the numbers up here. Sheet number 3 will be the trickier ones. So look out for that if you feel like skipping ahead at any point. Okay, so triangle number 1. We have an angle that we want to find. We first want to find what is given to us, right? So we need to find an angle. Cool. That looks like the hypotenuse. So I'm writing in an H for hypotenuse. And then we know if it's opposite from the angle, then, well, it's opposite. O and an H, let's have a look. O and an H. There we go. We're right in the so to start with. Write that down. And we are looking for the angle, right? So if we're blocking this out, because that's what we're trying to find, we have opposite over hypotenuse. Then all we need to do is punch in the numbers. So opposite 6 over hypotenuse 12. Sure, you can do that in your head, but since we're using the calculator anyway, so 0.5, but that doesn't give us the angle yet, right? So now we need to put in the inverted sign, which in the calculator means second function, and the sign button, which gives us 30 degrees. Oh, I'm sorry, that's a little bit low. There you go. All right, hope that makes sense for the first one. Let's move on to the second one. We have an angle that we're trying to find. We have a hypotenuse, and we have something given to us that is right adjacent to our angle, which makes this an A. Now, looking at our triangle, SOHCAHTOA and TOA, we have an A and an H. Well, this has an H, this has an H, but only this one has an A and an H, so it'll be Ka. We're trying to find the angle, so we'll block out the C, because that's what we're trying to find. And it leaves us with A over H, adjacent over hypotenuse. Then we plug in the numbers, 5 over 10, which again gives us a 0.5, right? So 5 over 10, there we go, 0.5. And we're within cos, we need to do second function cos to get that angle, right? So cos and the inverted function, which gets us 60 degrees. Okay. Then we'll move on to our last one on this page. That over here. Okay, we have an angle up here. The hypotenuse does not seem to matter. There's nothing there, but we have something adjacent to our angle, and we have something opposite to our angle. A and O, no hypotenuse. We know immediately that we are within the TOA. We're trying to find the T, so we'll block that out. T equals opposite over adjacent. Excellent. Now we plug in the numbers. We have opposite 5 over adjacent 10. Again, gets us 0.5, but check this out. 5 over 10 gets us the 0.5. Second function, tan. Always good to write that in there so you remember what you did, especially if you come back in a later year to review and you've forgotten all about it. So 26.565 degrees. Now, if I wanted to turn this into degrees, minutes, and seconds, second function, degree button, gets us the 26 degrees, 33 minutes, and 54 seconds. Now, what I find fascinating is that all of these ratios were 0.5, right? It was 6 over 12, 5 over 10, and 5 over 10. So 0.5, 0.5, and 0.5 ratios. But look how different the angles are. And that's the magic of our SOHCAHTOA trigonometry, that you can have the same ratio, but by using the different functions, they look wildly different. I just think that that's cool. Okay, so we're moving on to sheet number 2. A little bit more practice with the easier ones. Okay, so again, if you feel super comfortable, you can skip ahead a few minutes to sheet number 3, where we get into something a little bit more involved and tricky, but really it's just bigger and more awkward numbers. So as long as you punch it all in right, you're good. Okay, first step, we have an angle. First, we need to find what we have. We have a hypotenuse and we have something adjacent. Looking at our triangles, I'm going to go with Ka. We're looking for the C, right? We're looking for the angle. So C equals A over H. So adjacent over hypotenuse, which means 4 over 5. 4 over 5 gets us 0.8. And we need to do the inverted function of cosine. So second function, cos, gets us 36.869 degrees. Now let's keep practicing our DMS button. So second function, DMS. Move this up a little bit. There we go. Gets us 36 degrees, 52 minutes, and we'll round up to 12 seconds. Excellent. Let's move on to the next one. We have an angle. It looks like there's a hypotenuse involved, and there is an adjacent. So we are within Ka once again, right? We have an adjacent and hypotenuse. Write that down so we don't forget. We're trying to find the angle, so we're blocking out the C. What's left is A over H. Plug in those numbers. A for adjacent, 7.47. H for hypotenuse, 9.79. 7.47 divided by 9.79 gives us a ratio, 0.763. And we're doing the inverted cosine function. Second function, cos, gives us 40.269 degrees for the angle that we were looking for. Again, second function, DMS button, gets us the degrees, minutes, and seconds. Okay, let's do one more of these. Okay, so we have an angle. The hypotenuse is not involved, so that means immediately we know it's going to be TOA, but let's make sure that we mark our sides properly, otherwise we'll get into trouble later. So opposite is this one, and then adjacent, right, to the angle is here, but it's never the hypotenuse. Okay, so we're trying to find the T, so I can blot out the T, and what's left is opposite over adjacent, O over A. Popping in those numbers, 5.98 over 9.66. I'll just write it right here. 5.98, punching it into the calculator, divided by 9.66. 0.619. And squeezing in there, inverted tan function, which is second function tan. Says 31.759 degrees. And if we hit the second function and degree or DMS button, it gets us the 31 degrees, 45 minutes, and 34 seconds. Oh, and that's a bit too low. There you go. Those are the basics. That's how you always approach it. So let's move forward to a worksheet, three more problems that are just a little bit more tricky, just because there's a little bit more information involved. But really, it's the same process every single time. And we just need to make sure that we keep our wits about us so that we don't get confuse ourselves, which is really the biggest issue usually. And you can see we're on sheet number 3 for those who wanted to skip ahead. Okay, so on this one, there are several things we want to find. First, we want to find the hypotenuse. We want to find an angle A and an angle B. And we have the two sides given to us. So easiest to start with, finding the hypotenuse, a squared plus b squared equals c squared. Pythagorean. Let's figure that one out first. So 850 squared plus 1100 squared equals second function, and that square button gets us the square root equals 1390. Excellent. 1390. Put that in here, 1390, so we can keep track and know what we've already figured out. Fantastic. So let's see, if we have the option of using the numbers that are given to us, that's always a good option because we know those are correct. If you think, I'm not sure if I did that right, to find another side, just go with a function that uses the ones that you already have. So let's try for angle A first. Now, for angle A, what do we have here? We have what would be considered an adjacent side and an opposite side, which means, looking at our triangles, TOA, because we're not going to include the hypotenuse in this calculation. So blocking out the T leaves us with opposite over adjacent. Let's check that out. Opposite over adjacent, so 1100 over 850. 1100 over 850. And again, that just gives us the ratio. I'm just going to pop that down here. So 1.2941, and then we take inverted tan function to find out the actual degree. So second function tan, 52.306, or hitting the DMS button. Oopsies. Gets us to 52 degrees, 18 minutes, and 21 seconds. Great. Now for B, we have the same, we're going to use the same equation or the same function. You could choose a totally different one, but we're just going to keep it the same. So with B here, the opposite and adjacent are going to get mixed up, right? So I'm just going to erase those so we don't confuse ourselves again. Well, not again, just in the first place, because now this is going to be the opposite and this is going to be the adjacent side. Right? So opposite over adjacent, let's pop in those numbers. Opposite, 850 over 1100. And you notice it's the same numbers, but we're flipping them for the other angle. So 850 over 1100, 0.773. Inverted tan function gives us 37.694 degrees. And if we change that into degrees, minutes, and seconds, we get 37 degrees, 41 minutes, and 39 seconds. Awesome. I hope that made a little bit of sense. We'll do two more just to help you get the gist. And I scribbled over. Apologies for that. Okay, here's our second one. So we have an angle given to us. We have a side given to us, and we want to find out this side, and we want to find out the hypotenuse. and also an angle. So there's lots going on here. So what if we want to find the hypotenuse first? We have an angle. That means this side would be an opposite, and this is a hypotenuse. So looking at our triangles, opposite and hypotenuse leaves us with the so. Always write that in. So if we're going to find the hypotenuse first, we're going to block that out, which leaves us with O opposite over our sine number or our degrees. Pop that in. So 400 for opposite. And then our 17 degrees, 56 minutes, and 47 seconds, which should then spit out the length for our hypotenuse. So 400 over 7, that's the same DMS button we're going to use now. So 17 degrees, DMS button, 56 minutes, DMS button, 47 seconds, and the seconds are already there, equals. I forgot to hit the sine button. There we go. Okay, one more time. 400 over, there we go, sine of 17 degrees, 56 minutes, and 47 seconds. There we go. That looks like it. There's no way that the hypotenuse was going to be 22, right? So most likely that's going to happen to you. Always use your brain. Stop for a moment. Think, does that make sense or does it not make sense? Maybe you forgot to press a button. Very normal. There are a lot of buttons we press in a day. So 1298 for the hypotenuse. Awesome. 1298. Cool. Just in case we want to work with it. Now let's figure out our x side. We can use Pythagorean again. So 1298 squared. So c squared minus b squared equals a squared, right? Minus 400 squared should give us x. So 1298 squared minus 400 squared equals second function, and the square root button gets me the square root, gets me to 1235. Awesome. Fantastic. Now we have one more thing we want to find out. We would like to know what angle B is. So if we want to stick with the so, what do we need? So this is the angle. For the so, we need an opposite side, which we now have, because this would be considered our adjacent. And we need the hypotenuse, which we also have. So hooray. Okay, so let's find that out again. So sine equals opposite over hypotenuse. Okay, so now we can punch in those numbers. Opposite is our x, right? There we go. So 1235 over our hypotenuse, 1298. So 1235 over 1298. Now that gives us the ratio again. So 0.951, and we need the inverted sine function. Second function sine gives us 72.05, oopsie, 076 degrees. Second function and DMS button gets us to 72 degrees, 4 minutes, and 32 seconds. So while it can feel like a lot when you're looking at this, it's just breaking it down one step by step by step. What do you have? What makes sense? What can we figure out first so we can populate the area? So I have one more exercise for us to go through. There we go. Just one more and then that's it. Okay. So We have a triangle, we have a side given to us, we have a hypotenuse given to us. We want to find out angle A, angle B, and we want to find out what the side is. Well, let's get to it. Let's start with angle A. If we wanted to start here, what do we have? What can we use to find out that angle? So this one is the hypotenuse, we know that. And for angle A, well, this would be an adjacent, right? So if we have an adjacent and a hypotenuse, let's look. No, there's an opposite. Ooh, yes, there it is. There it is. There we go. Ha. So we want to find out the angle, which means C equals adjacent over hypotenuse. And you notice I write this down every time, and not just in teaching videos like this, but in real life when I do math, I write it out every single time. It makes you, or it helps you remember it better. And if you're punching anything in wrong, or maybe you're flipping the numbers, then you can go back and troubleshoot. Makes it quite a bit easier. So A over H, 490 over 1342.6. And that's going to give us a ratio. So 490 over 1342.6, 0.36. Let's call it 5. Second function, and we're in cosine, will give us the degrees. So cos inverted gets us 68.595 degrees. Second function, DMS button, gets us to 68 degrees, 35 minutes, and let's call it 41 seconds. Cool. So that gives us angle A. Now, could we figure out the side X? Yeah, right? We could do Pythagorean again. So hypotenuse, C squared minus B squared equals A squared. So 1342.6 squared minus 490 squared equals, let's punch it into the calculator. 1342.6 squared minus 490 squared equals, second function, square root button. Cool, let's call that 1250. And we can write that in case we want to use it. So how about angle B? If we would like to stay within our CA, and you don't have to in any problems that you face, but in this example, we're going to. So for angle B, we have the hypotenuse already, but we also need an adjacent side, which now is this, right? If we wanted to, if you were unsure about how you got the side, you could, of course, use one of the other functions where you're using the opposite and the hypotenuse. So you could use so. That is up to you. But we're just going to stick with the CA here. So C equals adjacent or hypotenuse, which is here the 1250. That's our adjacent side to angle B, over the hypotenuse, so 1342.6. And again, that gives us the ratio, 1250 divided by 1342.6, 0.931. Second function, and we're within cosine, 21.404 degrees. And if we press the second function and DMS button, it gets us the 21 degrees, 24 minutes, and 15 seconds. And that is it. So just like before, for any of these, always look at what you have. First, do you see a triangle? If you have a more complex triangle or unilateral triangle where you may not have a 90-degree angle in one corner, figure out how can you break it up into what makes sense that you can use trigonometry in your favor. Find out what do you have, what do you need, which angles do you have, so you can figure out your whether you use SO, CA, or TOA. On any quiz, on any exam, draw these out for yourself. With the triangles, I find them hugely helpful so you can block out whichever letter you're trying to find. Write out the function every single time. Then you plug in the numbers. And remember that if you're trying to find the angle of something, what that ratio gives you, and then you still have to do the second function and then your function. So the inverted. And that's then how you get to your angle or your degrees. I hope that makes a little bit more sense for you and that trigonometry can be your friend from now on.